You can always learn how to utilize the latest kind of large language model, but if you don't really develop a deep understanding of eigenvectors, you won't understand why something like LoRa, which is a popular way of fine-tuning large language models that's grown recently, works so well, or really understand it off the bat.
Hey, my name is Felix Tia. I'm the host of the Culture of Code, where we invite experienced engineering leaders like engineering managers, software engineers, and product managers to come onto the show to share what they've learned about growing and succeeding in the tech industry. In today's episode, we have Dan Shiebler, head of machine learning and artificial intelligence at Abnormal Security, and was previously a machine learning engineering manager at Twitter. Welcome, Dan.
Thanks. Glad to be here.
Yeah, so you had roles as a machine learning engineer, as a manager, and also a data scientist in your career. For folks that might not be aware of the differences, can you tell us a little bit about how they're similar, how they're different from each other in your profession?
Totally. So what I've found is that the title can sometimes be a misleading term because companies will utilize titles for grouping people into different categories, different compensation bands, different organizations. Sometimes it doesn't always accurately represent the structure of the work itself. But in my experience, there's a few different kinds of jobs which we can group together. A data scientist in the most traditional sense is a little bit more focused on analytics, metrics, and sometimes some intersection with machine learning systems. But any time that there are core metrics for product performance, analyzing A/B tests, sometimes allocating budgets, these are things that data scientists, generally wielding a combination of Python notebooks and SQL, will go after and tend to. The term data scientist often refers to someone who spends a little bit less time working directly with production code, although sometimes that's very different from company to company. When I had the data scientist job title, I was at an organization that did have me intersecting with production code. But at both Twitter and in my current company, Abnormal Security, data scientists tend to interface much more with metrics code only as opposed to code that would run as part of the customer experience. And then the distinction between a machine learning engineer and software engineer really is also a very fuzzy distinction. Sometimes companies will utilize the term machine learning engineer to refer to anyone who touches machine learning at all. At other times, the distinction would be a machine learning engineer is someone who explicitly trains and deploys models, whereas people who are, for instance, working on systems that feed features to machine learning models would be characterized as software engineers. This naming is a little bit inconsistent in my experience at both at Twitter and Abnormal Security, but really you could think about the difference as being whether you are, as your day-to-day job, working on iterating on improving a particular model that's going to go into production, impact the customer, impact core metrics, or if you're thinking about the data systems that need to be in place to feed those models, or the infrastructure that needs to serve those models and have them be running in a production environment. In these latter two cases, some of the challenges tend to be more traditional distributed system software challenges. Metrics like cost and latency tend to be things that you think about more, whereas in this former case, there's a great deal of non-production code writing and performance metric iteration that you would think about. But these lines can be very blurry. In some organizations, there's one person who does all of these things, and other ones, these people can be very far apart.
Awesome. Appreciate the dive in there. What about the transition? Let's say that someone is currently a more generalist software engineer wants to explore one of these two paths, either machine learning, as you had described it, or the data science route. How do you see that transition happening? What do they need to focus on? Is it a transition you see that's common? And what have you seen as a successful transition from more of a generalist like software engineer into one of these more specialized fields?
I'd say the most common transition that I see is someone who's working on back-end software engineering, especially things that have to do with data already, starting to become more and more involved with machine learning models, probably initially via the route of working on data that's utilized to feed machine learning models or systems that are utilized to serve machine learning models, and then getting closer and closer iteratively to training and deploying the models themselves, which is really the kind of most machine learning centric component of the process. Although I'd highlight that all of these are parts that are equally important, often equally compensated, and equal opportunity for impact in each of these different areas of the machine learning lifecycle. But serving features to machine learning models and deploying machine learning models are things that do not require a tremendous amount of knowledge of how the models were trained to begin with or how the models are evaluated. And the most difficult parts there really are distributed systems software engineering. I see that as a very common entry point for people with software engineering backgrounds looking to develop themselves more in the machine learning and artificial intelligence spaces.
Got it. So usually people that are on the periphery at first, where maybe you're working on data pipelines or applying the models to then transitioning into more of the training side. And speaking of training, I think even the phrase of the training models has been something that's only been popularized recently, or at least more known mainstream recently with things like ChatGPT 3 versus 4, these different models. I'm not even sure they're considered like models in like the traditional sense, but what does it mean to actually like train a model? Let's say that you are peeking into the day-to-day life of a machine learning engineer that is responsible for improving and training models. What does your day look like?
This is something that has changed a great deal just over the last year or so, I would say. So looking at, maybe more than a year ago, what this would look like is you have an internal data sets that your company owns, and your goal is to utilize this data set to generate a model that will perform some task at some performance. Ideally, and most likely, your company already has some system that performs this task. Maybe this is ranking content for recommendation. Maybe this is estimating risk, an insurance pipeline, maybe doing a type of classification of different kinds of content. It could be any number of things. There's some sort of heuristic systems that are in place, and you need to improve this. And so usually this breaks down into first identifying the problem that you're trying to solve, really characterizing this ideally with metrics to understand where are we at right now and where do we want to get to. Then consolidating the data that you have into a data set. Sometimes this is a single snapshot of data if you'd hired a team of human labelers to give you one set of data. Or if you're utilizing things like user actions as data, like, for example, at Twitter, user clicks and likes and such for data. You're more subscribing to existing streams of data as opposed to consolidating some individual sub-data set. Regardless of which of those two routes that you're going, your next step is to pull this data into some environment, a notebook or a script or something, and then utilize tools like PyTorch, scikit-learn, TensorFlow, whatever is the type of tool that you want to produce your model, evaluate that model in this same environment that you utilize to train it, and then push it into some kind of live serving environment. Whether this might be a batch prediction or this might be an online prediction, depending on the dynamics of your environment and the types of technology that you'll utilize for these different kinds of deployment processes. It can be very, very different depending on exactly which type of organization you're in. And then your goal is to validate that indeed your model that's been incorporated into this final stage does produce that improvement in metrics that you had expected. And then this is usually an iterative process where you go through all of these steps in many iterations, many times as you make these systems better. So if you're working at a 0 to 1 kind of product, you may be consolidating each of these for the first time. Many engineers fit into, especially larger tech companies, will fit into teams that already have a process that does this to some extent and have the goal of making it 20% better or something like that. Things have changed a decent amount now with the latest increase in efficacy and usability of large language models as zero-shot classifiers for a number of different kinds of tasks. It's now often the case that much of the work that we would do for the initial consolidation of data and incorporation of data into models that are grown entirely out of the ground within the company can be supplanted or supplemented by the incorporation of externally trained models into the process. So this could be either taking a previously fine-tuned model online and fine-tuning it and improving its performance in your data. That's a strategy that's already been around for a very long time, and is very important to many different, has been important in workflows for decades. Or in some cases, taking something entirely off the shelf and then modifying how you represent your own data to it, something that we might call prompt engineering, to then perform your tasks. And so this is a totally new kind of way of utilizing external models and really changes the mechanisms of the training process. But I would say that the majority of organizations that utilize machine learning would fall into more of this initial kind of take data, train an internal model, and push it into production, because that's what drives the vast majority of revenue that's driven by machine learning today. and probably will continue to be that way for quite a while.
Yeah, and it sounds like there is a heavy emphasis or a big reliance on existing data to be there. Do you find then that machine learning and data science roles typically don't become available or become maybe needed until as companies at a certain scale versus, let's say, like a full stack or backend engineer usually is like needed from ground zero when you're building a company. Do you find that to be true or not true? Like, what are your thoughts on that?
Yeah, I would say generally that's true. The exception, of course, is if your company is based on machine learning to begin with. The company I work for right now, Abnormal Security, is an AI-based email security product. The initial set of employees included machine learning engineers. The co-founder, Sanjay, who's the CTO, worked on systems that looked very similar to what you might expect a machine learning engineer to be working on when building the initial version of the product. And so the acquisition of the appropriate amount of data, both public and proprietary, was required to be able to bootstrap the product to the level of initial release. That's not the case at a company like Twitter, for example, or a product like Twitter, where machine learning really is more of a accelerator for the product as opposed to something that's really required to get it off the ground. So I would say that certainly a backend engineer is going to be required at basically any kind of company that has more than like a landing page to their name, whereas a machine learning engineer is really critical in products that have machine learning at their core and a core add-on for larger companies of all sizes and types.
Yeah, I didn't realize that companies are able to kind of buy externally trained models and maybe, like you mentioned, like supplement it with internal data or however they want to use it. I didn't realize that was a thing. What about how do you see data being, I guess, the importance of data evolving over time, where there's in these internal data sets, I'm assuming they're proprietary. Do you see more kind of these walled gardens happening or more marketplaces where data is being sold? Like, how do you see it changing over time?
Yeah, it really depends on the type of product you're trying to solve. If you're working with text data or image data or sound data, for instance, then you'll have tremendous amounts of data sets, pre-trained models, et cetera, available to start with. If you're doing anything where you can represent your data as text, then you'll be able to go on Hugging Face and download state-of-the-art large language models, for instance, and really be able to hit the ground running with very little proprietary data of your own. If you're building a recommender system, on the other hand, or if you're trying to do pricing for a product, or if you're trying to do risk estimation, most likely the kind of data that you need is the kind of data that you can only really get by your own product iterating. And there's a wide range of things between these two extremes. Financial data, for instance, or commodities data. There's a lot of supply chain data. There are things where there are third-party sources that provide these data sources that you could purchase, subscribe to. Sometimes they're free, and you could build systems that are based on that. But there's, I would say, the majority of applications of machine learning within companies that drive substantial revenue probably would be characterized in this proprietary area. And then there's a few kinds of marquee data types where the public data is going to be far better than anything you do proprietary, just because of how much there is. Text and image are the two that really stand out there. And then a number of things that live on the spectrum between those.
Yeah, it sounds like there's a thriving and growing ecosystem of selling and buying models or in data. And I think when someone is thinking about learning to be a software engineer and they're learning the kind of the basics where they're learning on the side, there's always this recommendation to work on a side project, build a to-do list, build Twitter, like these kind of like small projects they can work on. What if you want to learn machine learning? Like, are there examples that someone can just kind of start tinkering around and learning how to build and train models?
Absolutely. I mean, certainly in the image and text space, it's very easy to go to Hugging Face, download some of the models that exist there, and try to get them to run on maybe on an AWS instance, and try to set up a small product that utilizes them, try to fine tune it on a set of data that you've found to be useful. This is something that's very easy to get off the ground with no requirement for having a proprietary data set of your own.
What about for anybody that's in college or entering college that is either eyeing machine learning or data science? And because like we were talking about earlier about how the roles and titles are kind of interchangeable, inconsistent, or blurry, is there kind of coursework that you recommend either, again, people that are in college or going to college focus on or try to get into to come out with more well-rounded knowledge to pursue these kind of careers?
Absolutely. Statistics and linear algebra are critical. You can't take too much probability statistics and linear algebra. There are critical and underpin everything that we've seen in machine learning. One of the benefits of college is that it's an opportunity to learn things at a level of depth that you will not learn later in your career. You can always learn how to utilize the latest kind of large language model, but if you don't really develop a deep understanding of eigenvectors, you won't understand why something like LoRa, which is a popular way of fine-tuning large language models that's grown recently, works so well, or really understand it off the bat. If the opportunity to dig and develop that knowledge at that slightly deeper level is only really available during college, and it's a crime to not really take advantage of it during that time. The more specialized knowledge is much easier to learn later on. So that's the first suggestion I would give. The second suggestion, of course, is internships. Internships where you work as a software engineer is more important than internships where you would work as a data scientist, I would say, just because the difficulty of really understanding how large company software systems work is not something that's easily communicated via projects that you might do in a university setting, and is very marketable. So the two suggestions I would have are linear algebra, statistics, and probability as coursework, and internships to fill the gap in software. With the combination of those two things, you're an extremely attractive candidate for any kind of machine learning engineering role, regardless of whether or not you've learned the latest jargon in large language model worlds.
What about your experience? Was there anything that was beyond the almost like table stakes kind of coursework that is useful, but still aided you in your career, either in your specific field now or just in general?
I mean, the example I gave was from my own experience. The probability and linear algebra is the types of courses that I've found to be extraordinarily useful. I enjoyed algorithms courses. I took quite a few of grad algorithms courses in undergrad. I did a PhD as well in some of the more theoretical aspects of machine learning. And I found that the deep abstract mathematics gave me an understanding of how things fit together that really appealed to me. That appealed more to the way that I think individually, though, and I found that it helps me view the work that I do through a number of different lenses and very principled standpoints, which I think is very useful for being able to draw insight from metrics and intuition for the kinds of projects that will yield value and the kinds that won't. But the foundations of probability and linear algebra cannot really be overstated in terms of their ability to support everything else, regardless of which direction you decide to take everything else with.
Yeah, speaking of your PhD, you pursued it while working full time with your full time job at Twitter. Can you share some specific strategies about how you're able to manage your time between pursuing this degree and also working full time job?
Totally. Well, one thing I did was my PhD was at the University of Oxford, and most of my Twitter coworkers were located in San Francisco. And there's basically no overlap between UK working hours and San Francisco working hours. So I spent most of my time located in New York, sometimes traveling between those two areas. And I'd spend my mornings, usually 5 a.m. to maybe noon, working on PhD things, then from noon until the evening, working on my job at Twitter. The largest strategy I would say that worked well for me was really leaning into the more theoretical aspects of my PhD, having this be a much less implementation-driven set of projects and more of math theory set of projects, because my job at Twitter was so implementation-driven. I find that stresses of a certain type can compound. If I'm dealing with debugging some weird distributed systems error at Twitter, I don't want to be dealing with debugging something in my PhD at the same time. I want to be thinking about math proofs that use a different part of your brain and engage me in a different way. And so I found in that way, each one served as a refuge from the other and complement each other.
Yeah, that's interesting thought that about how the type of work that you're spending time on can almost tap into different reserves and not necessarily the same one.
Yep.
And you mentioned earlier too about how you learn more about what kind of projects actually add value. You actually had a difficult experience where a project you worked on, a news article recommendation project, got canceled. What did you learn from this experience about how to kind of pick and choose? Maybe listeners out there might not be in a position to pick and choose, but at least try to guide their careers or their projects that they're placed on in a specific way so that they are picking projects that are going to be being shipped or being successful.
Well, one thing is to be extremely aggressive when structuring your project about thinning what's required to reach an end-to-end success. You want to have a path towards the initial product success, something that appears on end metrics, something that's surfaced to the user, something that actually drives concrete value externally, not just within your team, not just within the teams around you, but actually at a user level as quickly and simply as possible. And if your project is structured in a way where that value isn't going to come for, till the end of the quarter or the end of next quarter, then you're at an extremely high risk that if an intermediate step ends up becoming more difficult than you expect, then you'll end up driving no value at all. And that will look very bad for both things like promotions, your own growth, your own frustration and happiness and the success of your team. But it is usually very easy and within the control of any individual engineer to reorder milestones and to restructure a project. The core deliverables may be things that come down from above and you may not have control over earlier in your career, but the order in which things are structured and the way that you design the roadmap that you have is something that you have control over, even as a very junior engineer. And so I would suggest even if it seems like doing multiple things at once to build out a core platform layer, for instance, may make other things later on in the project simpler, it is worth making the project seem like it will take longer, seem like it will be harder, just to move that end user deliverable as early in the project as possible. The amount of benefits that has, both to the success of the overall project, the ability to get early feedback, the amount of buy-in that you'll have from external stakeholders really cannot be overstated. That was a lesson that this experience drove home very clear for me. It's one that I've taken and applied throughout the rest of my career.
I really appreciate you breaking down like that. It's almost like if you can show that there's some kind of impact, there's currency in that, where maybe a project might get canceled, but if you're already showing that it's being used or there's already some kind of impact, even though it's not the full-fledged, the scoped project is not fully complete, it might buy you time or buy you more, I guess, capitals for you to continue working on it.
People remember the impact that you've driven. They don't remember the things that you said you were going to do and didn't do. They remember the things that you actually did. And that's what matters for you as well. That's what actually matters for making the product better, building a better company. You're never going to be able to do everything. No company is ever going to be able to do everything that anyone ever thought they wanted to do. But if you are actually doing things and closing the loop, then you're making the thing better. You're making the product better. You're making your team more successful. You're growing your own career and establishing this currency.
Yeah, I think it's important where, engineers are not a monolith, but I think there's a very much logical kind of thinking involved where to build this whole project, I got to do this in a certain step-by-step order. Let's do the foundations first and kind of build from there. But you're saying shoot the whole thing all the way through first and then kind of add the meat onto it later, which I think is almost like counterintuitive, or at least not a typical way of maybe engineers approaching a project. But as you mentioned, it's what the company values. So I think it's important for people to consider optimizing for that. So
this is something that's important in any kind of project, but anything with machine learning and data science, it is absolutely critical because of the amount of risk that's involved in each intermediate stage. And so recommend this to anybody, but I recommend this especially when you're working with those kinds of technologies.
Awesome. So after your time at Twitter, you're now working at Abnormal Security, which is a pretty big shift, right? You shifted from a product-based company to now cybersecurity. What was that transition like?
Well, a number of people who work at Abnormal Security, the founders, they also worked at Twitter in the past. And so I'd known many of them from my time at Twitter. I really was attracted to the mission of Abnormal Security. Fighting cybercrime and stopping cyber attacks has very serious positive impact on the world. And so that really appeals to me, to be able to use my skills and talents to improve people's lives, reduce the amount of harm that's done by something that's really bad for society. I think that the core attitude that we take towards building the product and building the systems is definitely very informed by many of the strategies that we utilized at Twitter, and especially within ad tech at Twitter, because the core systems that we utilize to spot anomalies are architected in a very similar way to how we architected systems for identifying whether or not particular ads would be successful at Twitter. And this is because these are good ways to build systems that count lots of data and move things into feature space. And so this, I would say in a lot of ways, was a pretty natural transition, even as the domain itself shifted quite dramatically.
And one last question is, what would you say is one of the more common misconceptions that people outside of the machine learning world have about machine learning or machine learning engineering as a career path?
I would say probably the amount of time spent training models and thinking about modeling techniques as opposed to fitting the intricacies of any specific modeling technique into the domain that you're working on. The criticality of understanding the product, understanding the domain, understanding the way a model is going to be used, the way it's going to roll up into the overall product experience, and the kinds of challenges that arise from that integration tend to take up the vast majority of time. That tends to be the hardest set of problems, and it tends to be really what informs the most interesting and unique design decisions. So it makes the difference between people who are really great as machine learning engineers and people who are more run-of-the-mill. And it's generally less about the more researchy familiarity with the latest machine learning techniques. There are certainly cases where this isn't the case, and there are many differences and many different kinds of roles and different kinds of products where this trade-off is different. But I would say that majority of cases that I've seen, this type of product understanding pays very, very serious dividends for machine learning engineering.
Oh, that's awesome. I appreciate you sharing that. That's certainly a misconception I have, and I appreciate you sharing that with me. So thank you so much for your time. Dan Shiebler, Head of Machine Learning and Artificial Intelligence at Abnormal Security. Thank you again for coming on and sharing your experience and your advice with us.
Awesome. Great to chat, Felix. Thank you.
And that's all the time we have for this episode. Come join us next time on the Culture of Code. Again, my name is Felix Tia. Take care.